Often impulse questions will look at the graph of force versus time, because the area under that graph is equal to the impulse. If you think about speed, distance, time, the area under a velocity time graph is distance, because distance is speed times time. Now in this first graph, we've got the dummy being brought to a stop in a very short time, and therefore a large force is exerted. So the force time graph might look something like this. If we look at another example then, where the dummy is brought to a stop in a much longer time, using something like an airbag, then we find we get a different shape of graph. And what we find is that the airbag increases the time of contact and therefore decreases the force. Because if the velocity before the collision is the same in both cases and it comes to a rest in both cases, then the change in momentum in both cases is the same, and therefore the impulse is the same. Therefore the area under both these graphs must be the same. So if the time in the second graph is longer, the only way that you can have the same area under graph is if that's smaller. Quite often these graphs are approximated as kind of triangles. So you might be asked to work out the area under graph of these kind of triangular shapes. We wouldn't expect you to work out the area under graph of a curve. And that's the basic idea of how airbags can help reduce injury. So they reduce the average force on the dummy and therefore reduce the chance of injury.